Hello, welcome to The X. Have you ever wondered why the ocean appears blue? A seemingly simple question, yet it opens the door to a world of science and mystery. When you gaze out at the vast expanse of the sea, you are not just looking at water, but a complex interplay of light and matter. It's a common belief that the ocean is blue because it reflects the sky. That's a nice thought, isn't it? The ocean like a giant mirror simply copying the palette of the sky above. But if that were true, wouldn't the ocean appear gray on a cloudy day or black at night? Yet, regardless of the weather or time of day, the ocean still maintains that deep, mesmerizing blue. So, if it's not just a case of reflection, then what is it? What's the secret behind the ocean's captivating azure hue? Well, the answer might surprise you. But there's more to the story than just reflection. Let's dive deeper. To understand why the ocean is blue, we need to understand how light interacts with water. When we talk about light, we're actually talking about a spectrum of colors. Picture a rainbow, if you will. That's sunlight or white light broken down into all its various hues. From vibrant reds and oranges to cool blues and violets, sunlight carries all these colors within it. Now imagine this rainbow of light diving into the ocean. As it plunges into the water, two significant things happen: absorption and scattering. Absorption is when the water soaks up the light, while scattering is when the light is bounced around in different directions. Each color in our spectrum of sunlight has a different wavelength. Red, orange, and yellow, the colors of a beautiful sunset, have longer wavelengths. As these colors dive into the ocean, they are quickly absorbed by the water. They don't get very far before they are soaked up and disappear. On the other hand, blue light with its shorter wavelength is a bit of a marathon runner. It's absorbed less quickly by the water, allowing it to penetrate deeper, racing past its color companions. It dives deeper, reaching places the reds, oranges, and yellows could only dream of. But absorption is only half the story. There's also the scattering. As the light gets bounced around, some of it makes its way back up to the surface. And guess which color is the most likely to make this return journey? That's right, it's our marathon runner, the blue light. While the rest of the colors have been absorbed, the blue light has the stamina to be scattered back up to the surface and into our eyes. This journey of light, from the sun to the depths of the ocean and back again, is what gives the ocean its signature blue color. So the blue light is what remains and gets scattered back to our eyes, making the ocean appear blue. But what about the depth of the ocean? Does it play a role? Well, it certainly does. The depth of the ocean significantly contributes to the blue color we see. Let's dive deep into this concept. As light penetrates the water, it gets absorbed by the water molecules. The red, orange, yellow, and green parts of the light spectrum are absorbed first and at a relatively shallow depth. However, as we go deeper, less and less light is reflected back to the surface. This is because the blue and violet parts of the light spectrum are absorbed last and at much greater depths. Therefore, the deeper the water, the darker the blue. This is why, if you've ever been lucky enough to dive deep into the ocean, you would have noticed the water getting darker and darker the further you descend. So, the depth of the ocean and the way light interacts with water are responsible for the varying shades of blue we see. So to wrap it all up, we've dived deep into the mystery of why the ocean appears blue. It's all about the intriguing interplay of light and water. Remember, water absorbs colors in the red part of the light spectrum more readily than those in the blue part. This absorption of light is not a random act, but a selective process, favoring the longer wavelengths of red and leaving behind the shorter wavelengths of blue. This leftover blue light gets scattered around and is reflected back to our eyes, painting the ocean in its characteristic hue. But that's not all. The depth of the ocean also chips in, influencing the shade of blue we perceive. The deeper the water, the darker the blue, thanks to the increasing absorption and reduced scattering of light. So the next time you marvel at the beautiful blue ocean, you'll know exactly why it's that color. Thanks for watching. Subscribe for more and don't forget to share.